Okay, so obviously this cylinder's leaking, so we're gonna rebuild it. Already disconnected the lines. It's got this little keeper bolt up here. I got that out. I'm gonna go ahead and break these loose here. So the way this gland is held on, it's kind of unique. Other than on this machine, I've not seen one like this. But it's got these bolts. So it's an aluminum gland and it's got a steel plate on here, and then these Allen bolts, and this is what holds everything together here. So I'm gonna go ahead and, like I said, break all these loose, and then we'll see if we can get the pin out. There's one up there that's been rebuilt before, you can tell, and replaced a valve on it as well. I'll show you later. These are kind of cool. They're tunable cylinders, and it looks like this one, the tunable part's actually been deleted on, or maybe it just didn't have it from the factory, but the factory drawings show them on there, so I don't know. But anyway, it's obviously that the valve that allows it to be tunable on that one up there is new, but it shows signs of being beat on quite a bit with the sledgehammer, so I imagine it was hard to get off. So you can see how tight these are. That's why I'm doing them now. Well, nothing else can move. It won't be able to move much once I drop it down, once I get the pin out, but still. Just crack it loose now while everything's rigid. They're tight. Oh no. The paint in these things is pretty thick, so it's kind of hard to get the Allen wrench started in there. Come on. Oh, thank God. That one acts like it was going to strip out on me. Whew. Come on, get off there. Okay. Sweet. Those are all loose, so I'll worry about that later. Once this comes down, it's going to be laying here, so if you're trying to pull up on it, sometimes stuff like this will be tight enough that it'll just pick the whole thing up. So easier to break all these loose while everything's rigid, the pin's all still in it. So, okay, let's grab a sledgehammer. We'll see if we can knock this pin out of here. Make sure this line's out of the way, don't want to cut it. Be right back. See if the 3 pound will do it, or 2 pound. Whoop. That's not cool. Okay. Okay, it didn't move. You guys are, what you're stuck to is this thing here. Oops, staying on my wrenches, which is there to support the weight. But when I just tapped that, this thing popped out. So I'm gonna need to hook them hoses back up. It shouldn't leak because the O-ring that seals that is still sealed. I should be able to lift this up. We'll get this situated better. Give me just a second here. Okay, let's try this again. I went ahead and beat on a little bit with the sludge before I set you guys back up here. Hoses are disconnected again. I got this set up better this time, I think. And it is moving. Not much. Now, here's the problem. This is now flush, but I've got like 6 or so inches to go before it's actually free. Yeah, it's hard to get that. Well, anyway, I'll be beating on this for a minute. I gotta find something else to hold in there while I beat it. So, tell you what, I'll bring you guys back once I get this pin out, because that's all I'm doing is just beating on this. And yeah, so anyway, I gotta get this pin out. Once the pin is out, this whole thing should fall. I might put like a strap around that so that it doesn't just drop all the way down. That's probably a good idea. And my thought was, if I take these hoses off, that should basically, in theory, it should take all the pressure off. That way there's no way that it's in a bind in either direction. And oil came out, so I'm assuming that worked. So if I support this, that way the weight of the cylinder itself isn't on there, then in theory, maybe the pin will be easier to get out. I won't have to beat on it quite as much. But this is the keeper. The way it works, this just goes through the hole right there, and then it gets bolted on there. That's how they all are. See the way they're all set up. These ones are on the other side. So, and then I mentioned these being tunable. On all the other cylinders, there is an adjustable relief valve right here. This is the exception to the rule. You can see it right there. That thing. That is an adjustable relief valve, so you can loosen that nut, and then there's an Allen in the end of that, a hex head, and so then you can tighten that screw in and out and choose where that valve relieves, which determines how much pressure the cylinder ultimately sees. And I think in this case, so it's not necessarily about the pressure, it's about the flow. So at some point it stops flowing. There may not really be a relief valve, but it's flow control. And so you can choose how fast that cylinder is allowed to move. And there are, most of the cylinders on this machine are set up that way. I guess this one's different too. But anyway, I'll come back to you once I get this thing down and we'll pull it apart. Working on this boom lift, I've already started here, but I was thinking about it. I'm working on driving the pin out right now, but something needs to be said. Supporting this boom. Once these lines are disconnected, which they're already disconnected, but there's nothing any longer that's holding this boom up. So if you're under it and you disconnect those lines, it will fall and crush you like scissors in between there if you were in there. Very, very important when you're working on hydraulics to understand the passive energy just from the weight of this system. I'm not quite sure how this works. This thing right here, these are tunable cylinders though, and so this is like a flow control valve, but this one looks like it's just blanked off so that it just gets full pressure, full flow, whatever the system can give it on this particular block. But I don't know why they would put it there if that's the case. So my point is that might slow it down a little bit, but you got to be really cautious about that. So the first thing I did was set this up. So this is obviously some pretty heavy steel. That's 4x8 tubing, and it's 1/2 inch wall thickness. All of it is. You can see there, nice stout stuff. Now it's kind of supported by this piece up top here, which not the strongest thing in the world. It does have a little gusset in it there, but I think it's going to be adequate. Like I said, all the weight of it is currently sitting on it, but make sure anytime you're working on hydraulics, even if it's a tractor or something, you know, let's look at my tractors right here. If you were taking, say, this cylinder apart, if you need more room, you need to have the cylinder extended a little bit, then you need to set the forks on something solid to take that weight And even just having, you know, they make blocks that you can put in here to hold the cylinder up while you're working underneath of it. That won't work though while you're taking the cylinder apart, because you have to get it out. So you have to find something to artificially support the loader in this case to keep it up, because if you're hunched underneath here, you know, in this fairly tight spot, and you know, I would fit in there, but not very well. And if you take those lines apart and this thing's up, it's gonna fall. This thing's even worse, because to get to the lines, to take them apart, you've got to have your whole body up in here, right? And the other one's back here on the other side. So very important, if you're gonna do your own hydraulic work, understand that potential energy, that gravitational potential that is just, it exists there until you support it on something. Because if you take those lines apart, the weight of it will just squish all that oil out. And it's a little bit different because it's got that kind of metering block on there, but even then it's still going to come down. And if you don't catch it, I mean, imagine if you had your head in here, right, and this thing collapses. These, whenever it's fully collapsed, they're, I mean, only a couple inches apart, and your head's not going to stop it from going there. You're just going to be squished and mouse trapped inside of that machine. So definitely just be aware of that, be very careful of that. And then the other reason I'm using this is because it's got an offset in it. And the reason it's up here instead of down here on this part is because it gives me this offset. So if you look where that cylinder is, where it's going to need to come out, I've got plenty of room, right? So I'll be able to pull that out, because it's 3.5 feet long, something like that. 3 feet, something like that long. And big boy cylinder is going to be heavy getting that rod out of there. But anyway, safety note, before you work on this stuff, make sure you've supported it adequately before you disconnect those lines, because it will kill you. So, all right, see you in a minute once we get this part. Remember yesterday when I was talking about not letting these things kill you? Well, I didn't understand how the cantilever system on that tower works. It about got me, but it didn't. So anyway, put stuff back together, try to get this thing safe before I go to bed here tonight. So I'll let you know how it goes here in a little bit. All right, everything's safe again. So the way this works, and I knew this, but I wasn't understanding it when I first tried to support it over here. These smaller bars, they're connected to each other. There's a big cast strap that ties them together. I can show it to you. Kind of. Well, not really. Anyway, the way that works is this one cylinder picks up, and then this bar here pulls on this one here, which pulls up there, and that causes both of these to open at the same time. So this part of the machine is called a tower. Other companies, I think Genie and like First Lift, they call it an elevator, but that's the tower portion. And then the long on the other side there that's actually connected to the basket, they call that the main boom lift. So it's the tower lift and then the main boom lift, or the main lift. So what I need to do in order to make this safe is actually support it between here. You can kind of see the wear mark where it sits on a pad in here somewhere. I need to support that. And if I can support that, then I should be able to take all the pressure off that cylinder. So what I'll do is just cut up one of these big pieces of tubing there. We'll cut up a piece of that as long as I can get it, and I'll use a tractor and we'll stick it in there. And then that should work. And I should be able to support it just off of the, if I can fit it right there over that pad, that would work well. If not, I can put it on this counterweight here, but it just needs to connect this to this. So yeah, that's what I need to do. So everything is reconnected now. I was able to drive the pin out, and so I've got my my drift in there. That's going to be all right for now. Of course, I wouldn't want to run it that way, but it will lift it as much as I need, and I've retightened the lines. And yeah, anyway. So, all right, that'll be the plan. We'll cut up this stand here. I'll cut that up. This is scrap iron, by the way. It just happened to be kind of a cool stand, so I thought that was going to work real good. But anyway, it still will. We just need to cut it up, put it in there, and then that should do it. So That'll be tomorrow though, losing the light, so we'll see you then. All right, got this hydraulic cylinder apart. I'll show you my setup outside tomorrow. It got dark on me. I kind of beat this up a little bit, and I regret that I realized this is actually threaded. This is the piston, biggest pistons I've ever taken apart. So there's wear bands that go here. These guys, and they're split. They just come off, and then this is the actual piston seal, and then got some O-rings in there and backups. And then this is the part that was actually leaking, so you can see, I don't know how well you can tell there, but this seal right here, that's the one's the problem, so we need to dig that out of there. So that's what we're gonna do. First things first is this rod wiper. That just pops out. Measure that. And now I need a pit. I don't have one out here. Let's see if I can use this bar wrench. So sometimes these seals have a energizer ring in them, and this is one of them. And it's probably hard to see on camera, but this is kind of a like an X profile. And that's important when we go to find the new seal. We'll need to know that shape, and that's going to help us find the new one. And there you go. That's the seal. What's left of it. That's why it was leaking. So now, obviously, there's not much left to measure on this, right? So we can measure the height of it here. Be able to measure that fairly easily. 200 thousandths. Let's see here. It's probably 5.14 millimeters. But this the outside diameter would be kind of hard to measure. But for that, I've got a special tool. This is a I was like, I'm gonna get this cleaned up. So this is an inside caliper. Oh man, it's not deep enough. Well, okay. Bummer. Okay, well, that's kind of a bummer. So we'll size it off the shaft, and I'll have to figure out a different way to measure that. I need spring caliper. I think I've got one. It's in my camper trailer. I'll have to go get it. So anyway, other than that, there is O-ring on the outside here, and then 2 wear bands in here. And this O-ring has a backup on it, backup ring. And that's it. That's all there is to it. Right, so need O-ring, backup, 2 wear bands, seal, rod wiper, O-ring and backup in here. And this seal, I may actually just keep this seal. It looks great, and that's not what was leaking on there. So I may just not even worry about it. But it's an odd setup. And the reason I kind of beat on it a little bit is because it has on this side, it's got one of these setups. So this is a taper, it matches a taper in here, and then you would draw those screws up, and then this pulls in there, and that's what locks it on. And so I assumed that that was all that was holding it, since they went to the trouble to put this on there. That's kind of a fancy part, just as a like a backup device. But then it's threaded as well, so that's kind of interesting. And then the other problem is, when I look up the parts diagram for this cylinder on JLG's website, it does not show this guy. This little, yeah, there you go, SDS2ML. That's what that part number's called. So I've never seen a cylinder built that had one of these on it at all, and then I don't really understand why they chose to use that. Kind of interesting. But then it's also threaded. So the diagram online shows a nut that's threaded onto the back side of this, and then a snap ring as a retainer. So this one's a little bit different, but anyway, like I said, I will show you tomorrow the setup. Oh, and then these are those valves I had mentioned before, and I'm not exactly sure how these work, but they require pressure. They have to have pressure on them in order to allow the cylinder to move. It won't let fluid flow in or out of the cylinder without having pressure. The idea being that if a hydraulic hose gets cut or blown off or something like that, it's not just going to drop the basket on you. And they do it that way because there's one for each direction. But it's done that way because they don't want to kill anybody, right? In the case of a hydraulic or a mechanical failure, the cylinder would literally have to like blow itself apart in order to actually drop the basket. So life support cylinder, right? These support people, so they're just built a little bit differently. And I'll go ahead and replace these O-rings. They're Viton, they look fine, but I'll go ahead and replace those while I'm in there, since I've got them out. And I had to take those out because even if you take the lines off, as I figured out, it won't allow air to move into the cylinder. It won't allow fluid to move out because there's no hydraulic pressure. So it's a backup. It's a fail-safe because it's a man lift and not a tractor. So, okay. Anyway, I'm going to sit down. We'll measure all these parts. Parts are in for this. Get this cleaned up one last time. Get her back on the machine here. So I already put this go ring on. Easy. Forgot to record that, but ain't nothing to it. See how difficult this seal is to get in. It's got this weird plastic thing. That's kind of weird. Put that in first. That's odd. Anyway, we'll see how hard this is to get in here. A lot of times these big ones are actually easier to work in than the smaller ones. Give you a little bit more room to kind of mess with them. I got all this from Hercules seals. Come on. They make it too. I ought to just buy it. It's like a weird pair of pliers that folds these things up so that you can get them in there. It's the same thing I'm doing with my fingers, but it's supposed to make it easier. Try this from the other side. That ain't fast. Yeah. Not too bad. Just weird plastic thing. This is supposed to be like a heavier duty seal than just a standard one. I guess that's what the plastic thing's all about. Ta-da! Where's these? These are real easy to put in because they're split. then rod wiper. Now a lot of people think, it's a real common misconception, that this is the seal. Whenever they see these leaking, they think that's the actual problem. All this is here for is to keep stuff from getting drawn back into the, like when the cylinder's retracting, if there's dirt and dust and stuff, it'll draw it in here and tear up the seal. This is just here to scrape all that off. It's just called a rod wiper. That's all it does. This doesn't actually hold any pressure. It looks kind of like a oil seal that you would see on like an engine, like a rear main seal. And it's the same sort of deal, but its purpose here is not to seal anything. It's just here to scrape all the crap, any water, anything like that off the cylinder. Like that. It would be better to actually press those on, but the hammer works just fine. Later. All right. Piston. Should get a bit smaller O-ring. And then this one, remember there's two backups. So the O-ring's got to go in between them. There's that. And then bigger words. These, by the way, are they're PA6. And they are 60% glass filled. So what that means, this is nylon. There's a bunch of tiny, tiny little bitty, like almost microscopic glass fibers that they fill in there. It's a kind of a reinforcement, makes it harder, makes the plastic stiffer. A few reasons to put it in there. That's what those are typically made out of. PA6 or PA66. And then glass filled, GF60, 60% glass filled. They're just slightly bigger diameter than the metal part of the piston here, outside diameter of it. The idea being that they will wear before the cylinder does or the piston does, so they're just they kind of take the brunt of the load. There's all the part numbers that I ordered there. Prices. So the only thing that's kind of sucks about buying stuff from like Hercules or whatever is like the O-rings here. I needed one of those, and they come in a 20-pack, so they're 52 cents a piece. But you got to buy 20 of them. Those big ones, they're $1.50 a piece. But you got to buy 5 of them. I only needed one of them as well. But all good. Still, the seal kit for this cylinder from JLG, they wanted $544 for it, and all those parts I just put on there, even with all the extra O-rings that I ended up with, was like $80 landed. So a lot cheaper at the end of the day. Probably going to drop that. Sometimes seals are hard to get started. when they're new. It's got a nice taper on it. Okay. This thing's next. I don't really know why they built this the way they did with this thing in there. It's just a big chunk of steel. And it does have a set screw in it. But I don't know what the point of it is. It's just like a spacer of some sort. Okay, and then this is actually threaded on. This way. I think it's just like, I don't know, maybe something in the threads or whatever. But it's kind of hard to get off of there. Just because it's hard to hold on to that real slick, shiny cylinder, or rod, I mean. It's going on pretty good, though. Yeah, that's it. I think. That's it. And then this thing. The way these work, these bolts, let me see what I'm doing here. Light's right in your eyes. There we go. So these bolts, there's two sets of holes in here. I'll show you. Right, so there's a set of holes that they're in now, which are just clearance holes, and then these are threaded. So you stick this on here, and then these screws will draw this thing down onto the cylinder, and it drives this, probably hard to see, but that is a tapered collar, and the piston here has a matching taper. So that draws it down in there, and whenever you take this off, you put them in the threaded holes, and then so your retaining bolts here become jack bolts. And so then you incrementally drive those down, and that pushes this thing out of there. It's kind of tight fit, which is good. Now, we can turn this a little bit. Yeah, still a little off. Get the holes lined up. There. That. I'm not sure what the follow over. If there's a torque spec I should follow on that. Probably doesn't really matter. Set this back up here. Oh, this thing. Here. This has a set screw in it. I guess this is just stroke limiting. I don't really know what the purpose of it is, but whatever. This sucker's all there. I'll tell you that. Okay, cool. Okay, well that's everything put back together. I'll look up the torque spec. It's just a 1/4-20 screw. It won't be very much. I'll show you this. I never did show you our setup out here. Well, this is it though. You see this thing here. That's my support. That's where I had to set it. And then of course that cylinder goes in here. So, all right. Awesome. Well, I'm gonna see if I had a neighbor come help me pull this apart. I'm gonna see if he's free again, and if he is, we'll get this thing put back together. Cylinder is back on. I did realize when I went to put this on here, I forgot to put this metal ring on here. There's like a I don't know why they did that instead of just washers, but anyway, there's a metal ring that goes on the outside of that gland, so I had to take it back apart. Put that on there, but a neighbor helped me and got it shoved in there. Went really good, actually. Didn't have any trouble. So anyway, test everything out. It works. And so why don't you guys come along with me? Here's a minute. We'll do the first actual job with this. I've got this light here, and there's another one that goes on this side of the building. So I'm going to go ahead and get that installed. And then if I don't lose the daylight, I'm going to start installing what's called a PL and a F&J trim up top, and that so my wall steel will go up into that and my soffit will go into it that way. So once I get that done, and then I get the rest of this rat guard trim put on, and then there's J channel that goes around all of my penetrations. Once that's done, then I'm ready to start putting wall steel on. So anyway, get that light put up today, and then maybe get started on that. So anyway, let me gather up some tools and stuff, and we'll get to it. I don't know how well this video is going to come out. It's kind of shaky looking. But I got to go up there and take some measurements on that one anyway, because I don't remember what my numbers were. So while I'm up there, I'm going to go ahead and put the J channel on that first light. Well, let's try this thing out. Alright, so this control is really slow. I got to figure out what's going on with that, and it doesn't go as far as it should. So still got to work on that and figure it out, but I want to just use this thing for a little bit and see what else I might need to do to it. I'm not sure. So anyway, the tower lift part, it works fine. So I can still get plenty tall enough for what I need to do. It'll take me. It's going further right now than it did the other day when I was testing it. I think it's something to do with those tunable valves on the cylinder is what I suspect. So I need to just lock this thing up and then take it apart and see maybe if there's an obvious seal that's bad or something like that. I'm not sure. Going up pretty good right now, just slow. part of why I think it's that valve, because I think the oil's warmer whenever it's thicker whenever it's cooler. So I just started this thing, so the oil's going to be as cool as it can be, and so if it's a seal that's failing, that would kind of make sense. There's calls I need to be right there. And it's not meant to be fast, you know, they're meant to be slow and controlled, so that's not necessarily a bad thing. And I still need to anchor my foot pedal. There's a pedal you have to step on down here in order to make any of the controls work. So I need to get some bolts and just bolt it back down to the floor on this new basket. You know, one other thing we'll see here in just a minute, now that I'm thinking about it, this particular lift does not go 360 degrees. You know, it can travel that full 360, but there's a stop halfway, and then you have to go around the other way. I think, actually, to reach where I need to be, I think I'm going to end up having to go the other direction. So we'll see, but I think it's going to stop me here in just a second. We'll see. And maybe that might be far enough I can just drive forward, although I put that piece of steel right in my way. Oh, okay, cool. I went the right way. I couldn't remember which direction will get me over here. I'm gonna do some work on this tree at some point as well. Probably thinking about doing it today, but I don't know. I might wait for winter. Measurement that I needed, just this. I remember how tall I put the bottom of this block. So that is 138 inches. Okay, so the idea with these white blocks that I've mounted everything to is that I can trim around these just the way I would do like a window or door or anything else. So what we'll do is we'll put the sides and the bottom piece on. I'll leave the top piece off, and that way I can kind of slide the sheet metal in. You can actually get the sheet metal on it, and then I'll cut the sheet metal and slip the head flashing in. And of course I'll show you guys all that whenever we get to it, which will be a little while now. So anyway, I've got some J-channel up here, and my snips. This should be 1 foot. And from 1 foot, I want to clean it. This will be the first J-channel I've done, ever actually. I don't mess it up too many times before I break my blade. Something's not right. This thing doesn't want to drive. Go backwards. Very slowly. But I can't hardly. Won't hardly go forward. Try swinging myself around straight. It might have a safety that won't let it, that makes it go slower when it's got a sensor. It knows whenever I'm lined up straight, and then it'll artificially sort of slow you down when you're off in a weird angle like that. So maybe if I straighten it out, it'll let me drive forward. Anyway, as I slowly continue to go around in a circle here, thanks for watching, guys. That boom's fixed. Obviously it works, and did one small job with it. So I'll continue to keep you guys updated on it as I keep troubleshooting, fixing things, and figuring it out. So anyway, till then, see you guys on the next one. Thanks for watching.